Okay, we're going through the do now for May 5th, and on here we were being asked to convert these decimals into, actually what we're doing is creating scientific notation. And to put this in scientific notation, we have to move this decimal here over 1, 2, 3 places so that we have one whole number to the left of the decimal. And that makes it scientific notation. So we put the 1 here, and we multiply that by 10 to the minus 3, because we can't change this number. We're just changing how we write it. Okay? So the 10 to the minus 3 will take the decimal from this position and move it to this position. And we come back with the same number. Is that cool? All right. Now, over here, we had 1, 2, 3, 4, 5 zeros, and then we had a 3. And there's no numbers to the right of the 3, so we can't write anything but the 3. And I'm trying to keep this really, really simple because it helps you understand what's happening with powers of 10. Now, how many, if I move the decimal to here, how many do I have to make my power of 10 to get it back where it was originally? 6. Okay, so and that's a minus because we're going to the left to take it back. So we start with the decimal here now, and we move it back 6 to the left. Now, extra credit, anybody who can lift your hand and tell me, how do I look at my number of zeros and get a power of 10 that will work to put the zeros back, or to put the decimal back where it was? Okay. Right here. What was, how could I get this 6 over on the problem that we were just finished with, this guy? How can I get this minus 6 and how can I get this minus 3 just by looking at the zeros? Who can tell me? What?
Number of zeros plus 1.
Number of zeros plus 1. Perfect. Okay, so here we had how many zeros? Anybody remember?
10.
That was 10 zeros. Okay? So, what is the power of 10 going to be? 11. Minus 11. Absolutely. So, this is going to be 9 times 10 to the minus 11. Are we good? Yeah? All right. Let's do the strong acid. And for that, let's call on Guyane, not here. Instead of Guyane, we will get Smith, not here. Ida, tell us, what's a strong acid? No idea. Kevin? Kevin? Do you have it? Shh. Okay, this is an acid, ionizes. I'm going to put words in your mouth and say ionizes 100%. Good example, hydrochloric acid. I have 1 mole per liter of hydrochloric acid. How many moles per liter of hydrogen will I have when I dissolve all of that hydrochloric acid, or hydrogen chloride it would be, when I dissolve all the hydrogen chloride in the water and it all separates, how many moles of hydrogen will I have from the 1 molar hydrogen chloride? Let me say it again. If I take 1 mole of hydrogen chloride and I put it into 1 liter of solution, that'll be 1 molar, right? Okay, but it doesn't stay as hydrogen chloride. It goes from HCl to, what do you think? Hydrogen ions and chloride ions. 100%. You don't see a backward arrow there, do you? It's not an equilibrium deal. It just doesn't want to be there. Okay, as this stuff, as this guy right here, it wants to be in the water as these 2 guys. So if I have 1 mole of this, how many moles of this am I going to get? That was 1 mole of this. How many moles of hydrogen do I get? 1. Yeah. So if this guy is 1 molar, he's not really going to be 1 molar hydrogen chloride. He's going to be 1 molar what? H plus. Yeah. And that H plus is going to immediately ionize in the water to form H3O, the hydronium ion. But this acid ionizes 100%, and that's good for a stamp, Kevin. And Edgar H., how about it? A weak acid, what is that?
An acid ionizes only partially in dilute or current solution.
Good. Ionizes less than 100%. Okay, we call that a weak acid. That's the definition of a weak acid. It doesn't matter how much hydrogen is in the water. It only matters it doesn't matter how much hydrogen is in the water. It has to do with whether it ionizes 100% or not. So a little bit of a strong acid goes a long way in terms of producing hydrogen ions and bringing the pH down. What's neutral pH? 7. Okay, what's acid pH? 0 to 7. And actually it goes to -1, by the way, for pHs. They can they will go down. pHs can go down under 1 or under 0. They can get to -1. It's just a real concentrated solution. That's all. Very, very concentrated. Okay, Edgar, you get a stamp for that. And what is pH, Ella?
A negative logarithm of the hydrogen ion concentration.
Okay. This guy is the negative log of the H plus concentration. And that's where we're going to get into some really interesting stuff that you're going to see in just a minute. Let's look at the website, and I'm going to show you here we go. Okay, right here. Please. Okay, right here, you're going to see a link for a chart to calculate pHs. And in here, you're going to see how to go about doing an actual log, how to log something. You can do it with a calculator, but it's much easier to do this method. People who do it on calculators usually mess it up. If they understand how to do this method, they're going to do great. And for this, I have 2 videos for you that you can watch, and you can get this again. Let's go to my website. I'll show you where I picked that up to put it in that page so you can look at it anytime. I'm going to tutorials under Learning Center, and when I go down here to acids and bases and I look at the very last tutorial, that's the link that will take you to the screen we were just looking on. Please spend some time with that this weekend. Look at those 2 videos and you'll come back a logarithm expert. Okay, that's it for today.